Hello everyone, hope you all are doing well. So today we are going to discuss the next answer copy of our Aspire for Agriculture test reach. Aspire for Agriculture test reach. So in the previous video, we have done the section A of test 4. We have discussed the section A of test 4. So today we will be discussing the section B of test 4. Okay. Which is generally we will see the questions of plant physiology. In section A we saw the questions of forestry. In section B we will saw the questions we will see the questions of plant physiology. This is because till test 8 we have sectional tests. Okay, in total we had 14 tests. So let's start the section B of test 4, and by discussing these types of answer copies, by analyzing these types of answer copies, it could be very helpful to you because you can see, understand how to introduce, how to conclude, how to write certain points, how to write certain examples, and you can learn from these mistakes of the student. So all these things can be very helpful to you. Now let's start. So the first question is, enlist the essential elements and discuss the criteria of essentiality. So there are 17 essential elements which the student has mentioned, and he has written an introduction about essential elements in brief, that it is vital for plant growth and development. Okay, these elements are involved in various metabolic functions. So we will see first of all those essential elements. So first of all we have macronutrients, that is needed in high amounts, and micronutrients, so it is needed in very less amounts but are important. So in macronutrients, the student has classified very well. First are basic elements, that is carbon, hydrogen, oxygen. Then we have primary elements, that is nitrogen, phosphorus, potassium. Then we have secondary elements, that is calcium, magnesium, sulfur. So these all are macronutrients. In macro, that is Mi, we have iron, manganese, copper, zinc, cobalt as cationic elements, and anionic elements are molybdenum, boron, vanadium, chlorine, and as beneficial element. So these are the macro and micro. Okay, both are both nutrients. Now we'll see criteria of essentiality. So this criteria of essentiality has been given by Arnon and Stout, and it is a very important question. Have been asked previously in UPSC several times. I think last year again it was asked. So you should know it. So it was given by Arnon and Stout. Now we will see what are the criteria. The first criteria is that the plant cannot complete its life cycle in the absence of the element. That is, that element is very necessary for the plant to complete its life cycle. Secondly, the action of element must be specific, with no other element being able to completely substitute it. Suppose we have nitrogen. So nitrogen has certain functions in the plant. So its functions would be like that other elements are not specifically able to replace it. Suppose nitrogen's function is same amount of calcium. If calcium is able to replace it easily, then it is not a essential nutrient. So this is the second criteria of essentiality. Third one is that the element must be shown to be directly involved in the nutrition of plant. Okay, it should be directly involved in nutrition of plant. So these are the criteria of essentiality which you should know. And again, well concluded. So this was the first question, and one thing I must add here, that I will be not discussing all the thing in very much detail. I will be just discussing the important points, the structure of the answer. So if you want to read the answers in detail, you can simply pause the video and read it. Now let's move to the next question. The next question is, describe the contact exchange theory in relation to ion absorption of roots. So what is contact exchange theory? So it was proposed by Jenny and Overstreet. In this theory, ions on the surface of root cells and clay particles evolve in constant oscillation and they got exchanged. So we will see. So a simple diagram could be made here. I will just try to explain it. Suppose here, okay. So this is, and this is clay particles. Okay. So here we have said let it be K plus ions. Here we have hydrogen ions. So what will happen? It will oscillate. After oscillating for some times, they will be get replaced with each other. So what it will become? Like this. It will become that the K plus ion will come in this side and hydrogen ion will come in this side. So this rotational exchange while in contact is known as contact exchange theory. If these two are in contact, they will exchange the ions. Now its uses have been mentioned. As I have mentioned here also, a simple diagram showing contact exchange can enhance your answer. And these are easy diagrams, so you should try to add it to your answers. Uses of contact exchange theory has been mentioned, such as explanation has been given, okay, understanding has been given, development of nutrition progress. So all these are uses. Limitations have been also mentioned. So you can simply pause and read it if you want to. Now let's move to the next question. The next question is, write a note on soil plant atmosphere continuum. Soil plant atmosphere continuum. So what is this? And it was also asked in this year's PYQs. So soil plant atmosphere continuum, SPAC, is the continuous path taken by water from the soil through the plant and the atmosphere. So this is soil plant atmosphere continuum. So water or moisture moves from soil to plant to atmosphere. So this is what soil plant atmosphere continuum is. So its basis have been given. It's based on the central idea that water moves from the areas of high potential of water to areas with low potential of water. Obviously, uses have been mentioned. Quantify water fluxes and hydraulic states used in agriculture and plant physiological research, hydrological and atmospheric science. The bulletin points. You can simply pause and read it if you want to. Factors affecting SPAC has been mentioned, such as soil properties, climate, plant physiology, atmosphere condition. So that is all, I think, and a good conclusion. Now let's move to the next question. The next question is, discuss the role of enzymes in vital activities of plants. So we will see the role of enzymes. So we all know what enzymes do. Enzymes act as a enhancing agent in any reaction. So it is a kind of act as a catalytic activity, enhances catalytic activity. So we will see the major role in photosynthesis. They have roles such as dehydrogenase has a role in photosynthesis, as it breaks hydrogen and oxygen from water. In Kelvin and dark reaction, it has a role. So you can simply pause and read it. In respiration, oxidase, reductase, all these have roles. Carbon fixation have roles of enzymes. So, almost all the activities of plants have role in enzyme, but in answer you can see it is not easy to write because you have to remember the names of enzymes which we have to give in examples. So that is a very well written answer by a student. You can simply pause and read it if you want to. They have role in defense mechanism, ethylene production, breaking down complex substances, and every one answer you can see the examples of enzymes have been provided. So well written answer. Now let's move to the next question. The next question is, differentiate between C3 and C4 plants. So C3 plants are defined as plants that use the C3 pathway on dark reaction of photosynthesis, while C4 plants are plants using C4 pathway. Okay. So the major differences have been mentioned. First of all, it is about C3 plants. It is a cool season plants. The product is 3 carbon compound that is waved. Phosphoglyceric acid. Then it is 95% of the total green plants on the earth are C3 plants. It generally prosper in temperate climates. It has cryogenotomy. So it does not have cryogenotomy. C4 plants have cryogenotomy. C3 plants possess only one CO2 acceptor. So these are all about C3 plants. You can simply pause and read it. Here dark reaction is placed in mesophyll cells. So well written points. Pause and read it. Examples have been also mentioned, so the rice, wheat, oats, sunflower, all are C3 plants. Now let's move to the C4 plants. So these are warm season plants. Generally, we will see these in arid areas, and its for carbon compound is OAA, that is oxaloacetic acid. About 5% of plants are C4 plants on earth. They possess the cryogenotomy that I have mentioned here. Consists, so all well written points. I think it will be a very long video if we discuss every point in detail. I have discussed all these things in my static videos. So if you want to refer the conceptual clarity, you can refer those. This is just a structural answer writing view video. Okay, I will just giving the structure of answer through copies of students. So I will be not going in that much detail. You can simply pause and read it if you want to. Examples of C4 have been given, that is maize, sugar, coin, cypress species, etc. and a well-written conclusion. Now let's move to the next question. The next question is discuss in detail the mechanism of mineral salt absorption in detail. So we'll see how mineral salt is absorbed. So its mechanism have been mentioned. The first one is the passive absorption. We all know there are two types, passive absorption and active absorption. So passive absorption we will see. So the concept explains that mineral salts are not affected by temperature and metabolic. These are the things you can should read it. Here various theories of passive exchange are there, such as mass flow theory. Then we have ion exchange hypothesis. So you can simply pause and read it. Contact exchange theory we have. It is a type of ion exchange theory only. Then we have carbonic exchange theory. Then we have Donan equilibrium. So these are the various theories of passive absorption. Now we go to active absorption. So it is an important point. Energy driven absorption of free ions is known as active absorption. So here energy driven, that is active absorption needs energy, while in passive absorption there is no need of energy. So you can again simply pause and read it. Its major hypotheses are carrier concept, carrier mechanism, involved cytochrome pump theory. So these are the major hypotheses. First of all, carrier concept theory is given, and you can see how well the student has made a diagram and explained the things. So that is very good. That is well written answer. You can simply pause and read it. Cytochrome pump theory has been explained. Now let's move to the next question. The next question is enlist plant growth regulators and discuss the commercial applications of PGRs. So we all know what plant growth regulators are. So various PGRs are auxin. Its functions have been mentioned. Promotes root growth. Prevents the fall of leaves. Examples have been mentioned such as IA, IBA, 2,4-D. All these are examples of auxin. Then we have gibberellins. Increases axis length, promotes shoot development, delays enzymes. So all these are the examples of these examples of gibberellins are GA, GA2, GA3, GA1 to 3. Cytokinins, cytokinins. I think in the question it was mentioned that enlist and explain its commercial uses. So what a student has done, it has written normal use also. So you could avoid it or you could be very brief in it, okay? Because you have to give most emphasis on commercial usage, and we have to just enlist the these PGRs. But student has written too much on it. So writing too much is not bad thing, but you have to complete the answer in time also. If you give too much time in an answer, how will you be able to complete 20 questions in 3 hours? That is why you should be very specific in your answer. Abscisic acid functions are mentioned, ethylene's functions are mentioned. So you can simply pause and read it. Now, what are the commercial application of PGR? It was exclusively asked in questions, so it should be given more focus. That is auxin, help in plant propagation, they help in parthenocarpy, 2,4-D uses as weedicide or herbicide, GA3 has been mentioned, helps in sugarcane development, or you can say it helps in the elongation of sugarcane nodes. So relating points, you can simply pause and read it. Abscisic acid is very much anti-transparent hormone. Ethylene is helpful in ripening of fruits. So very well written points. You can pause and read the points if you want to. Now let's move to the next question. The next question is differentiate between transpiration and guttation. So we'll see what the differences are. First of all, the student has mentioned about transpiration. So it removes excess water through stomata. Water is if you are writing differences, I think this format is more feasible. I am not saying that this format is wrong. You can go with this, but if you go with this format, this looks more feasible because at the same time examiner can read the both of the points similarly. So you can go for this format because it is more feasible. This is not wrong, but that is more feasible. Water is evaporated as water vapor occurs during the day. So we all know what transpiration is. All things have been mentioned. You can simply pause and read it. Next, about guttation, we have mentioned removes water through tentacles, hydrophones. This is important. It removes water through hydrophones. Lost as liquid water only. In transpiration, it was gaseous occur. It occurs during night or early morning. In transpiration, it's generally the day. You can see here no such cooling effect is seen, because here there is no evaporation, kind of no gaseous exchange of water, but in transpiration it can be seen. So well-written points occurs at low temperature, not the case for transpiration. So good written points, you can simply pause and read it. And when concluded. So this was the section B of test 4, and I hope you have read the answers at period intervals and you have understand the structures of answer, which were our aim. So that is all for today. If you like it, please press the like button. Please do share and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis, and if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.